Alright. So we talked about a couple of things those last 3 days before we got into the finals week. And we started looking at the relationship between a function, its first derivative, and its second derivative. Okay? And we've discovered that the relationship between a function and its first derivative, that's something that everyone should have covered in their class at one point or another, is what? What does the first derivative tell us about the original function? Or what could it tell you? Very good. Where the original function is increasing or decreasing, and it can also tell us where I have what? Relative maximums or relative minimums, right? Where could relative mins or max occur? Only at what values? Critical numbers, right? Or critical values. And how do I find those critical values, or where do those occur? Anybody know? Where that first derivative is equal to 0 or undefined, right? So if I find those critical numbers, those are the possible places where I could have a relative max or a relative min, right? There has to be further analysis to decide whether it is a max or a min, or whether it isn't at all, right? And that's where we do a sign analysis. Do you remember doing like a sign line?
Yeah.
Yes? For example, something like this, right here.
Yeah.
So we do a sign analysis, and then we would pick values and plug them into the derivative to see what the sign of that derivative was, right? So for example, we discovered that our critical numbers here were -2, 1, and 4. Why are those our critical numbers?
That's why they.
Because the derivative is equal to 0. Is this the graph of the derivative?
Yes.
Yeah, so it's a list of slopes, right? Of the tangent lines of the original function, yes? So right here at the x-axis, it's listing at that value, what was the value of the slope there? 0. So at -2 it was 0. At 1 the slope was also 0, and also at 4, right? So those are our critical, what? Values. That's why I put them on my sign line here. Are we okay? Then what we do is we analyze the graph here because we're given a graph. If we don't have a graph but we have an equation, then we use the equation to do that, right? And we pick a number. So what would be a number between -3 and -2? -2.5. And what you would do with that number is you would plug it into the first derivative and check to see what sign you would get. So what sign should I get if I plug in -2.5 into the first derivative equation? A positive value, right? So that's what I write down in that intro. And then I draw a little line going up because it's showing that the function, the original one, should be what? Increasing in that intro. So on and so forth. So between -2 and 1, what was the value? It was negative, right? We're below the x-axis. Okay, how about between 1 and 4? Those are all negative numbers, right? Okay, how about between 4 and 5? Positive, right? So we label it, and then that makes it really easy for me to answer all of these or make all of these statements underneath. Okay? So the function should be increasing if the first derivative is what?
Greater than 0.
Greater than 0, meaning it's?
Positive.
Positive. The function is decreasing if the first derivative is?
Less than 0.
Less than 0 or?
Negative.
Negative. When do I have a relative maximum?
When it changes from positive to negative. When the derivative changes.
When the derivative changes from what?
Positive to negative.
Positive to negative. The original function would change from going what? Increasing to? Decreasing. That would make me have a max, right? And when would I have a relative min?
The derivative changes from negative to positive.
Very good. If the derivative changes from negative to positive, that's saying that the original function changes from what? Decreasing to increasing, forcing it to have a min. Are we okay with that? Yeah? Those are the two things that the first derivative tells you. It'll tell you your critical numbers, which are your possible maxes or mins, relative max or mins, and it'll also tell you the intervals of increasing or decreasing. Super easy? Yes? As we go throughout the rest of the week, we'll practice this a little bit more. We'll practice the sign lines in case you haven't done them, but we'll go from there. Okay? Basically, a derivative is what? When I find a derivative, what is it that I'm finding? A slope of a tangent line at some particular point, right? Okay. So if I want to get the derivative of the first derivative, what would I be finding?
Second derivative.
The second derivative. So now if I'm finding the derivative of the first derivative, I'm looking at the slopes of the tangent lines on what graph? On the first derivative graph, right? Okay, so we're gonna look at this first derivative graph right here. But now we're not looking at as a slope, a list of slopes, we're looking at as an actual graph, and we're imagining those tangent lines there. And we have to focus on the slopes of those tangent lines to be able to determine our second derivative features. So you can tell me what's happening in my second derivative using the first derivative graph. You think you can do that? Maybe?
Yes.
Yes? Alright, so can you first tell me where the second derivative will equal to 0? Do I have the notes? I didn't give you these?
No.
Just kidding. If you were in my class, you should have them. So take them out. If you weren't in my class, then you shouldn't have them. If you were in my class and you don't have them, I can, okay, awesome. You got any say yes? Yeah. You need one, Oscar? Yeah. If you want to copy the top part, I'll move it down a little bit. So you can have it complete. Those of you that were with me should have the top part, and that way you just fill in the bottom. Want me to bring it down?
Yeah.
Okay, I'll bring it down so you guys can copy that. I'm sorry. You misplaced it. Equal, that. I just assumed that everybody that was with me had it, but if you don't have it, I have more copies here, you can get one, okay? Cool?
Turned off.
Some of the days repeat, like there might be 2 day 25s, but like for the most part they're in that order. Yeah, I have my binder in order and you can just go through my binder. You can match.
No, we can just try.
Hot, man. Shouldn't have worn gloves. You're
Wait,
cold?
what's wrong with
No, it's because it's not moving.
Oh, you have to put it on the first one.
Uh-huh.
Like one click right after where you turn it on. If not, that's as fast as it's going. It either goes like super fast or like doesn't move at all.
I think it's
Ridiculous.
good like that.
Maybe they wired them wrong or something, I don't know.
What do you use for?
Like why would you make a speed like this? Like
I
what wind is it blowing, right?
know. I mean, that's better, but like,
Interesting.
I know.
I
I feel like off.
Ready, Alejandro? We have a tutor here, guys, Alejandro, so in case you ever need help, you can ask him.
Everything here?
He's a senor, yes?
What? Because you always walk in third block and I thought it was like.
In case you need a sharpener, I also have a nose sharpener. Put your pencil in there. It's cool, right?
Very cool.
It'd be cool if it like came out of the other nostril. Liquefied. These TMSA knows the numbers
Robert
that you get.
Tasty, dude. Robert Tasty.
Huh?
Did you guys get a
Whatever happened to what?
It's a maximum.
The number says? We're there, man.
You guys
Where you at? We need you to train the kids.
I was 20. Yeah, you already
Cool.
For real?
I'll give you half of the stipend. Half of the 2,500.
Nine.
That was you? Yeah, it was.
I love the masters that he has here. I was feel like so many.
All right, so can we continue?
Yes, sir.
Not ready. Take a picture. The teacher said take notes. You can if you want,
Oh, the eraser.
a little bit faster.
Are you recording?
Am I recording? Yes, I am. All right, so can we move on? If not, you can get this a little bit later. All right, so now let's look at this graph here, and can anybody tell me where the second derivative would equal to 0? That would mean that the slopes of the tangent lines on this graph would have to be what?
0.
0. So where could I draw a tangent line that would have a slope of 0?
You're negative 1.
At negative 1,
1,
okay, that would have a slope of 0.
1.
At 3, that would also have a slope of 0. At 1, I think I heard somebody say that. Where else?
Negative 3.
At negative 3, okay. At
5.
At 5. So these are all the places where if I drew a tangent line, the slope of that tangent line would be 0, right? And since I'm drawing tangent lines on the first derivative, then the slopes of those tangent lines actually represent the what derivative?
Second.
Second derivative. So anytime you draw tangent lines on something, it represents the next what? Derivative, where the slope of that tangent line represents the next derivative. Okay. Anybody know what those places are called, where the second derivative is equal to 0 or undefined? Possible points of inflection, right? Just like the first ones were critical values, those were possible maxes or mins, okay? These are also critical values, but I call them possible points of inflection because they could be where the graph changes what? Concavity. That's what a point of inflection is. Where the graph changes concavity. Concave up or concave down. You remember that? Yes? Alright, so now in order to figure all that out, we have to do a second derivative sign line. We have to do a sign analysis. Okay? So I'm going to put here or undefined, and these are my possible points of inflection. Where the graph changes what? Concavity. My daughters had cavities, they took them to the dentist. Tell you, it's gonna be expensive, they got my teeth. So let's do a sign analysis of the second derivative using the first derivative graph. Okay? So let's go ahead and label our possible points of inflection on the sign line. So we got one at negative 3, it just so happens that that's an endpoint. Okay, then leave a space. Then we got at negative 1, then leave a space, we got at 1, leave a space, we got what? 3, and then it's another endpoint which is 5. It's not going to go beyond that. Okay. So now when I look for the sign, do I have a second derivative to plug into? Plug numbers into? No. So what do I have to look at? So let's do on this graph that's going to help me determine the sign of the second derivative. The slopes of the tangent lines, right? So between negative 3 and negative 1, if I were to draw a tangent line there, what would the slope of all those tangent lines be? Negative. Okay, so the concavity here would be concave what? Down. So I draw a little parabola opening down. Okay. Between negative 1 and 1, what would the slopes be there? Positive slopes. So that's concave. Up. Did it change concavity?
Yes.
So is this a point of inflection for sure now?
Yes.
Yes, okay. How about between 1 and 3? What would the slopes of the tangent lines be there if I drew them?
Negative.
Negative. That's the only way to figure it out in this case, right? How about between 3 and 5? All of those slopes would be what? Positive. Awesome. We were able to determine a whole bunch of stuff about the second derivative using the first derivative graph. And most of the time, that's what they'll give you on the AP test. They'll give you a first derivative graph and ask you about the original function and also ask you about the second derivative. Okay? So from there, they'll ask you about the concavity. So the only way you can figure that out is by figuring out what's happening with the second derivative and then go from there. Sounds good? All right, so let's label what we can about the original function. So f of x is concave up on what intervals? Negative 1 to 1 in union with 3 to 5 because f double prime of x changes signs? No, it's greater than 0, right? So something is concave up if its second derivative is what? Greater than 0 or positive, right? Are we okay? Alright. F of x is concave down. On what intervals? -3 to -1 in union with 1 to 3, again because the second derivative is negative, right? Or in short terms, less than 0. Super easy? Okay, and the last part is describing the points of inflection, okay? So on the AP test, they usually, you gotta be careful, if they only say, tell me the x value at which a point of inflection occurs, then all you need is the x value. If they say, find the point of inflection, then notice the word that it starts with. What? Point, right? So a point is not only an x, it's a what? A y. So you would have to write the whole point, right? So you would know the x, how would I find the y? Plug it into the original equation, right? They wouldn't ask that in this particular case because we don't know anything about the original graph and I can't look at it and figure it out. Okay? So what would we say? F of x has a point of inflection